All right, ladies and gentlemen, this is going to be review video number 6, how to write full electron configurations. In the last video, we went over how to read electron configurations and what exactly they were describing, but I also said that you weren't really going to have to draw anything related to electron configurations. You were just going to have to write them out and understand what they mean. So remember, an electron configuration is literally just a code that tells you where the electrons are going to be located in an atom at any given time. And the way you write one out is you're going to use a variant of the periodic table like the one shown in the picture below and like you're going to get a copy of for your day-to-day stuff. All right? So in terms of the rules for how to do it, rule number 1 is always start at hydrogen if you're going to write a full configuration. So that means start in the upper left-hand corner where I put that red star every single time. Rule number 2 is that you're going to go through the periodic table from left to right, line by line, top to bottom, writing each time a piece of the code. And you're going to write a different piece of the code every time you see a different color orbital. So what I mean by that is you can see that different sections of the periodic table in this picture are different colors, right? You can see over here that all the ones that are labeled S are going to be that light blue, including this one right here, which is also a blue color. You can see that all the ones labeled P are going to be that like pinky kind of salmon color. You can see that all the ones labeled D are yellow, and you can see that all the ones labeled F are green. And otherwise, it looks like a normal periodic table. You're just seeing that labeling in the middle of each section. All right? So that's rule number 2. Every single time you read the periodic table, top to bottom, line by line, you're going to switch pieces of the code every time you see a new color. Rule number 3 is stop when you hit the element that you're trying to do. So let's say you were trying to do silicon right here. You're not going to keep going all the way down to lead. That doesn't make any sense. You're going to stop writing the code when you hit silicon. All right? Now, the easiest way to understand this is just to do it. So I'm going to walk you through a couple of examples just so that you know how to do simple ones, you know how to do more complex ones. All right? So the first element we're going to do is carbon, and I'm going to circle it in red so that we know where we're heading. Rule 1 says that we are going to start every single time at hydrogen, where this little red star is. So we're just going to start. The first part of my code has to start up at hydrogen. So I'm going to put that code, the number, the letter, and then a little exponent number for every piece of my code. I'm starting in the first row. So my first piece of that code should have the big number 1. Everything in row 1 is blue in color. So we see this box and this box are both blue in color, and they both have a letter S. So the letter portion of that code is going to be the letter S. In terms of how many electrons are going to occupy that 1s space, well, that's the amount of boxes that you see. There are 2 boxes in row 1 that are labeled S. So that little exponent number is going to be a 2, 1s2. All right, now I'm going to cross them out since we've done that. We're crossing that out, we're crossing that out. Now I need to go down a row because, again, we're going to read the periodic table just like we would read lines of text. And we're going to go to row 2, which means the next piece of my code starts with a big 2. The first part of that code is a 2 because we're in row 2, but the second part is a letter. So the first letter type that I see in row 2 is blue in color. It's S. These 2 boxes are S, so we're going to put an S. There are 2 boxes that are that color within row 2, so we're going to write a little 2 as an exponent. And then I'm done with them. Now, we're almost to carbon. Carbon is right here. So we're going to write a new piece of the code because now I have hit another color. We're still in row 2, so my big number is still going to be 2. But now my letter is different because I've hit a different color. So we notice that this is P now, so our letter is going to be P. And carbon is the second box in that row. So my little exponent number is going to be a 2 because I've gone through 2 boxes. And now that I've hit carbon, I'm done. We're going to do another example, another couple of them actually, so that you can get the hang of this. The next element that we're going to try to find is silver, Ag. Silver is a lot farther down the periodic table. It's right there, so we're going to have a much longer code this time. But we are still going to start at hydrogen. We're still going to read the periodic table line by line until we're done. All right? So, silver, I'm going to do it in a different color, still starts up at hydrogen. We're still going to start there. So we're still going to start in row 1. The type of orbital that I see in row 1 is S. There's still 2 boxes that are S in that row. So my first piece of that configuration is still 1s2. Now I'm going to jump down to row 2. The first letter type that I see in row 2 is S. So I have 2s. There's 2 boxes that are that color within that row. So my exponent is a 2. I'm not done with row 2 though. I'm going to go all the way across and finish it out. The next letter type that I see in row 2 is P. So I have 2p. And there are 1, 2, 3, 4, 5, 6 boxes that are P boxes within row 2. So my little exponent will be a 6. Next, I'm in row 3. Row 3, first letter I see is S. There's 2 total boxes that are S in row 3. I go all the way across. And now I hit a P, still in row 3. But now my letter is P, and there are 6 total boxes that are P boxes within that row. Now I get to jump down to row 4. Next piece of my code will be 4s2. Now, when we hit a D box, and that's that yellow group, there is a little bit of a switch that happens, and you probably, if you've been looking ahead, already noticed it. This piece is labeled 3D, not 4. The reason that that is because electrons that hang out in 3D orbitals have just slightly less energy associated with them than 4s and 4p. So the principal quantum number actually shifts back a little bit. And it is a little bit confusing if you're trying to remember to write it out and you don't have this specific picture that just kind of labels it for you, but you will get used to it as you go. So I know that this last piece of the code that we wrote was 4s, but now we're going to move across this area, and that is going to be 3D. So the next piece of our code is going to be 3D, and you just count your boxes like normal. And there are 10 boxes within that space. So our little exponent is going to be 10. After that, we hit the 4p section, and that's going to be 4p6. Below that, we're going to hit 5s2. And then finally, we've reached where silver is, and we're going to stop at silver. And so that last piece of our code is going to be 4d9, because silver is that 9th box within that space. All right. All right, last example is going to be lead. So once again, we're going to start up at hydrogen. I'm going to go through this one a little bit quicker until I get to where it starts to deviate from the pattern. So we're going to start at 1s2, just like before. Then we have 2s2. Then we have 2p6, 3s2, 3p6, 4s2, and then remember, once you hit a yellow box, it switches back one principal quantum number, so our next piece is going to be 3d10. Then we're going to do 4p6, 5s2, 4d10, 5p6, and then 6s2. Now, I'm going to slow down a little bit here because something a little bit odd is going to happen with this F block down here. So our last piece that we just wrote is 6s2. Lead, where we're heading, is over here. In the middle is the F block. The F block is removed from the rest of the periodic table because all of the elements within it act like the two that are circled in red right here, La and AC. That F block, when you are writing a configuration, literally goes right in this space that I'm highlighting in yellow right there. So literally, after 6s2, you'll go down here and you'll do this bit, 4f14, because imagine that entire 4f bit is smushed and put right here. So we have 6s2, then we have 4f14, and then we go back to the rest of the D block, and we have 5d10. Then we hit where lead actually is, and it's the second box over in that 6p row. So the last piece of our code would be 6p2. If you have any trouble writing electron configuration, I'm happy to go over specific examples, and you're going to have to do specific examples in the review assignment. But again, please always ask if you need help.